Good morning. Good morning, Namaskar. Good morning, everybody. Namaskar. This is Engineer Suraj Singh speaking from Bharat, India on this day, February 23, 2022, Wednesday, 3:53 a.m. मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ। आज तारीख 23 फरवरी 2022 बुधवार का दिन सुबह के 3:53 एंड कंटिन्यूएशन ऑफ टॉक क्वालिटी प्रोजेक्ट वर्क्स. Quality projects works. You can see this title, Quality Projects Works. Coordination world, communication, network, concrete, civil field engineering, reliable engineers for contracts, safety designs, construction methods, claims organizations, and here is certificates. As you can see, this is my email address. Line and engineering, NGINER at yahoo.co.uk, and this is my. Then you can say my certification, International Professional Engineer India, INTP India. This is valid for 5 years and up to 30th September 2025. And this is Chartered Engineer Certificate based on corporate membership of Institution of Engineers India. And this is also according to provisions of Royal Charter 1935. And this fellow membership that is called FIE from Institution of Engineers India according to Charter. And this is file of coordination engineering and this is file of quality engineering, on which I'm going to focus on both these files. Within this talk, I repeat this is my name board, this is my competence certificate, this is my regular competence certificate. This I'm saying regular and this is saying instant because this is valid for 5 years and this is valid to an extent. Membership, as you can see clearly, by virtue of qualification, professional training, and corporate membership of this institution. So, if you are not corporate member, you cannot use Chartered Engineer India. But in INTP, you have to get approval every 5 years, and there's nothing as such corporate membership here. It is such person is authorized to use style and title International Professional Engineer India, and this is representation because IEI or Institution of Engineers India that we call it. It represents our country, Bharat, India, on international agreement, and that's International Professional Engineers Agreement. So this is only beauty of this designation, that this is on elite countries in engineering. Not all world, few advanced countries are members of this agreement. That's called I. Because I have to discuss on quality and coordination, which are main subjects of this talk, main topics. This is quality, and because I am inclined to discuss about topic itself, is quality projects works. Signals are always down, again down, and that's the problem here. Quality projects works. I'm going to talk about works. I'm going to talk about coordination world, and of course communication, which are very important these days. Coordination word, because everybody does not understand this. Coordination is such a word which is known to everyone, but nobody realizes what it is, how important is that, how significant is that. And communication is nowadays like a game. It's like you have to communicate for nothing. You have to communicate for sake of communication only in personal life, but in professional life, it's different type of communication. Means you have to be creative one and you have to be communicative one. And communicative means every issue is communicated properly, even to yourself and to others. So coordination and communication is a kind of thread, you can say. It's a thread of a string, or you can say like a formula in life. Without it, nothing can move in communication. Communication depends on network itself. Network is in its your electronic network, or otherwise your personal network, or your own system. Or even if you are not using computer at that time, there is communication, and you have to talk to people, you have to converse with them, you have to instruct some people physically or in office or elsewhere. So communication has varieties of its applications, we can say. And same way coordination world has also got varieties of applications, because it depends on what type of communications we do. And of course we can say there is civil field engineering, and civil I'm saying is for people, it's not for all people around world. And field means practical work done is called field here, according to me. It's not simply go to field or go to some land. Everybody is on land already. But field is where practical work is done in whatever form. It is design, or it is conception, or it is practical engineering on site, or it is construction, or it is, you can say, manufacturing or processing, or whatever you can say, for people whatever is done, for country whatever is done, or for world whatever is done. That's called civil field engineering. And then I say reliable engineering, so it's a very important title. Though it's not an official title, but it's property based title, it's character based title, it's performance based title. What is reliable engineer? Engineer who has got safety, who has got complete acumen for safety, and who has got complete, you can say, service oriented mind, service oriented habits, service oriented performance or hands, and who got, who can work constantly for long time for same thing, even though there will be monotony on that, but that's called, as we say, reliable is that safety plus serviceability plus durability, and whatever else you can say added to that is called to reliable. So reliable engineers are those who have got same kind of properties or character, otherwise one cannot call itself reliable engineers only engineers. Reliability means one should win trust of people. People should trust him practically, should trust him professionally, should trust him that this person shall deliver what this person says, and we believe this person. And it should repeat all time. Every time you do some work, it should be worth, and it should be trustworthy, and people, yes, this must be like that. Even without even verification, they believe that you have such exposure that you whatever you do, whatever you say, you comply with that. And compliance is called engineering, and compliance is called every part of compliance is called, means whatever was required to be conducted, to be carried out, that has been done. And when we call works contracts, that's very important. Work contracts means every work has some context, even though it may not be in writing, but contract is contract, means two parties must move together on same track, which is called contract, with certain conditions, of course, certain responsibilities, some liabilities, and some accountabilities, and some scope of work, and some payment. All are involved contracts. We can say one should know what is scope of work and what is the responsibility of each other. Both parties, and minimum two parties are required in the contract, is a fact of life. First party and second party. One party pays money for some work, and other person delivers that work, performs that work. I mean, both the successful is called successful contract or performed contract. Otherwise, it's disputed contract. We can say there may be many disputes in same contract. We talk of that later on. Now, safety is also an issue. Safety of work and safety of person, safety of everything. Safety includes health, and it includes environment, and we have to talk of that. Also, in between sandwich discussion, we can say that designs and construction. Without designs, construction is not possible. And design is, you can say, fundamental of some work. And if you have good design, even though it may not be writing, but design means creation of mind and thinking of mind, and construction goes to implications of that design, application, implementation correctly. And we can then claims, we suppose some work is not done according to contract, or you can say there are disputes, then these organizations can go to claim. One may be claiming organization, other may be responding organizations, both are there. So this is just many types of miscellaneous or sandwich projects, sandwich titles, and that is therefore the quality and coordination one file. Quality and coordination is one file, and that's a very important file. We can say without quality, without coordination, we can't do anything. And if you say that it's this, it's this file coordination, and this is file quality. As I say, quality is also important. Both are important. Now we say quality and coordination, we have to talk together, and we have to work with these two. Without quality, we cannot do anything. And if we do something or do anything without quality, we waste time, and we waste material, we waste all resources, because quality is not achieved. And quality means whatever prescribed for that is specified for that. And that is specifications within our hands, and according to some regulations, according to certain requirements and technical quality, we can say quality is constituted, or we describe what we have to do within this limit. These are few points. We say according to this, you have to comply with these conditions. We call that specifications, or we call technical conditions, or we call whatever else. This technical condition is very important, because contracts are framed. Because if you comply with qualities, conditions, or technical conditions, specifications, you can see you are going to comply with contract requirements. So contract requirement is technical conditions, specifications, or whatever contents on there, were designs on that, or the detailings on that, all must be complied with. And that's because all, you can say summary of all, you can say comprehension of that mandate, that you have to comply with all these requirements are included in contract conditions. Indirectly, though not specified, contract conditions include everything, and as we call contract document itself. And contract document means you have to comply with all technical requirements, conditional requirements, non-technical requirements, work requirements, or conventional requirements, or codes requirements, or whatever else you can say that contract is included in quality and coordinations are therefore important. All these conditions you have to talk about, all these specifications we have to talk about, design we have to talk about, first be mutually explanatory and mutually understandable. We cannot say I agree with this document, I don't agree on that document. That doesn't work. You have to consider all documents together and whatever all documents speak we have to do, and that's called requirement. It's a quality requirement, and that requirement is a question of quality within that prescribed limit, within that prescribed descriptions the quality is contained in. And that's why it's a coordination. Coordination means all these should talk together, nothing should duplicate away. No item, no condition, no descriptions should run about. Yes, there may be something superfluous in that can be clarified, or something may be deficient which can also be clarified. So quality and conditions, so quality and coordination, these work together, and the coordination clearly means that it should speak. It should speak something, it should say something. And it means that it should depend on other requirements, and if we don't do that, means we make mistakes, and that's very important point here. Quality and coordination, this is actually a basic requirement. Without that we cannot do anything. Quality and coordination is a combination, and that's the reason I'm taking this file with me, and I produce another file with that in continuation of that one. That's called quality and coordination, and it is called coordination engineering projects public and engineers. समन्वय अभियंत्री योजनाएं अभियंताएं सावजन in Hindi. I just translated for all those who maybe would like to see Hindi language here because of this country. Though Hindi is not only used in this country, Hindi is used in many other countries. So it's bad because many thousands of millions of workers work in Gulf countries, particularly construction workers or shop workers or others who know Hindi also. In addition to their own languages, there sometimes we have to help them. So that's why I just keep few words here for Samanvaya, Abhiyantri and Samanvaya and Yojana and Eventime and Sarvajanik. It's only for that purpose, otherwise this English talk and this, because it's very difficult to talk in Hindi all the time. I don't know many Hindi words, so I don't say that it's good for me, it's bad for me, but because my field has been engineering and usually work in English language, so English is also considered my language. I say Hindi is my mother tongue, but English is my work tongue. You can say work tongue. We write in English, we write, we work, we think, and we speak in English. So it doesn't matter, it's a part of my life. Same way Hindi is the original part of our life, and regional languages are part of people who stay in those areas, and that's why we have to be very careful about this. Respectable language, every language is respectable, and we have to think of quality rather than language. Is very important part of quality should be thought of. You don't think of quality, you cannot get it, though quality is an integrated part of life. Everybody has some quality system, every work has quality system, every part of life is quality based, and we have to prescribe that. And that's, we say that you are not following this or that, we sometimes blame someone, but we don't prescribe, we don't explain. Actually it's explanation that is required. In fact, if you raise something and there's no response on that, nobody can explain to you. Say, no, you do like this, and there's arbitrary order, you can say. An arbitrary order is not acceptable. Yes, it is acceptable as far as you have authority, but you should explain that in law language. You can say it should be speaking one. And speaking doesn't mean speech only, it means clarity. Clarity of something. Even though you write something, so speaking the document, means this has to answer all the contents in this, all questions in that. And that is called speaking order, speaking writing, speaking, or speech itself is a conversation. So we have to understand this was in a very practical way. Just like we say, judge always says your order should be speaking one. You should tell. And just like usually say, one should be clear about what is done, what is being done. That's a very important part in life. We cannot sleep on something. We have to speak. We have to clear. No, just like we say in engineering. In engineering, we say in engineering speaking is different actually, because in engineering we say clear concept is a must. Clear concept is a must in engineering. Particularly, we say when we say define engineering or define engineering of this work, we can say you must be clear about this what you are going to do. Concept should be clear and method should be clear. Otherwise, we say something is susceptible or doubtful, and in particular civil construction, because civil construction costs heavily, it costs time, it costs resources, and it is real application on sites. It's not like other disciplines or other branches of engineering, like mechanical engineering, electrical engineering, IT engineering, others engineering, which are done elsewhere. If you notice, mechanical engineering is done particularly in workshops or in factories. Very little part is done on sites. Machines are ready-made. Ready-made, I mean to say, they are manufactured and delivered in certain form. You just install them or commission them. Otherwise, electrical items are also, particularly transformers, switch gears, switchboards, panels, and everything is ready-made. Conduits are ready-made, wires are ready-made, cables are ready-made. These are delivered. Only work you have to do, fix them or install them. Same way IT, same way furnishing, only work that is done on site, that is construction. We really call it construction, not exactly erection. Construction, or you can say kind of work manufacturing that is done on site, and that is absolutely, for example, structural items, we can say structural or in between structural and finishes, like in say installation of brickwork or installation of block work or mixing of concrete. All these are very important activities without which nothing can move. And that point we have to understand. In civil construction, if you just leave behind precast concrete or pre-stressed concrete or structural steel, though structural is a mechanical item itself, because it is manufactured by mechanical engineers, only erection is done on site. So we can say civil engineering is that world where manufacturing itself is done on site, though we don't call it manufacturer, we call casting concrete or pouring concrete or work of concrete, like that. Though purpose is same, destination is something is produced, and manufacturing is production. We produce concrete, we produce a structure on sites according to designs. So you can say civil construction is different world. It cannot be compared to others, though all are integrated together, all aligned together. Without alliance nothing can move, and that's fact. Without alliance nothing can move and should not move. So we can say we can differentiate. I think exceptional case is civil engineering, which is supported by mechanical engineering, electrical engineering, IT engineering, and architectural engineering, and many other branches of engineering in certain parts, in certain proportions. And that's what we consider. That's why I say quality is important. I don't say quality is not worked upon in other branches too, but performance doesn't happen. There is a difference between other branch and civil engineering. Many times I say, and always everybody can understand if you pinpoint. Otherwise nobody cares. Long life. If we compare lifetimes, how long shall some items stay? That becomes a question always. And we say, if you consider civil engineering, here products stay at one place, and these stay for decades together. Mechanical items can be replaced immediately, urgently, whenever required. I'm sorry. For example, we have generator, electric generator, we have transformer, we have switch gear in electrical, mechanical, and many more items, machines, or whatever else which is functioning or which is commissioned already. which has been known, but we can replace this within a couple of days. We just shut down something and replace it and put another one. But in civil engineering construction, this doesn't appeal, this doesn't happen. Replacement is either it's very expensive, total expensive, or it doesn't mean anything. You have to allow civil construction forever. Once it is constructed, it becomes an asset. No depreciation practically. Maybe people count that in valuation, but speaking otherwise, it is a kind of product you use for more than your life. I mean, your life may be limited, but that product can be used by your survivors as well. And that's why I say civil engineering, civil construction is different. And that's also reason I always bring to everybody's attention issue of quality, because if quality is compromised, it's not done according to requirement, we cannot get that work done and be used for so long life, long decade, can say many decades. Therefore, system of engineering construction in civil is little different. We should conduct otherwise means we should not take it equivalent to all others. You see, when you manufacture a machine, there's a set procedure. It will be manufactured accordingly. Complete sets are there. There can be no variation because generally everything is mechanized, automated. Even if not automated, there can be no major changes because it is cutting, fabrication, or you can say whatever else, making some design, applying that design, and parts accuracy is important. In mechanical world, accuracy is more important. Speed may not be that important, but everything is machined, everything is, you can say manual contribution is lesser than mechanical contribution. Supervision may be important, and you can say accuracy is much higher than possible. That you use raw materials. Only branch of engineering is where raw materials or direct materials from nature are used. Stone aggregates very important, and because dust very important, sand is very important, and cement production. Cement is not natural. This means limestone is important, silica is important, admixtures are important there. We have to take that into our this type of consideration, and we have to consider construction differently, but it doesn't happen. It's otherwise reverse. People don't understand what is engineering, and major projects even on where people are qualified, people are well as educated in engineering, they to ignore, and that upsets everyone. That upsets me at least. If I think in engineering terms, if I think in quality terms, that upsets me, because we forget that this work shall be used for decades to come. How many engineers keep in mind this? I don't know. Maybe design engineers think so, but design engineering is part of engineering. It's not full engineering until that work is done. If that work is done practically in field, and only then we can say engineering is over. And it should be done safe, it should be done serviceable, it should give service, it should run with that service forever. But does it happen? It doesn't happen because of many reasons. That's why I particularly focus on designs also, not procedures of designs, but value of design. Design engineering is a part of civil engineering as well as construction engineering, because what we are going to construct is designs. It is design that we construct, and This means design is integrated to construction, integrated with construction. If construction is not done, this means design is not effective. Designers also should understand this point. You cannot isolate yourself from field, from works, civil engineering, construction works. And this means you may isolate from product quantity, but you cannot isolate from quality. It's duty of designer to tell, to instruct, or to communicate in whatever way possible to that person who has to construct on site. You should think your mind, whatever it says, whatever you transport into mind of that person, or what I should transmit through writings or through instructions or through specifications. Specifications one should understand it's a part of designs. Specification, not you cannot say specification is not my responsibility. Specification means what is your value in designs. It is a specification that tells what standard of design it is. It's not simply drawing sections, plans, elevations, structural detailing or reinforcement. It's not design alone. What is required in this, that is also specification. And it may be your own or it may be copied one. You have to select. It's up to you, up to designer. We can say major part of contracts, major part is constituted of specifications, general as well as project. It's very important calling, it's very important import, it's very important part, it's very important documentation of specifications. And not only specifications in writing, specifications of sketches, how to show, how to work. I say even drawings have specifications. Sections have specifications. These specify something. It's not line work alone. So specifications constitute major part of contracts. If you say conditions in contract, which you take in contract forms, these are conditions of contract. That may be even not even 1% of documentation. If you count page wise, in some contracts you will find thousands and thousands of documents, and out of those thousands, many 100 pages of specification. And then you can say, otherwise there may be 10 pages or 15 pages or 20 pages of contract. So if you see proportion of contract document is limited to, you can say, as far as conditions are concerned. This means major part is composed of specifications or such drawings. And that's why I say contract is technical one. Technical one. This contract is not just contract in pages. It's technical one, and technical one means it is in hands of engineers, in hands of those who work either in designs or on sites or in field. And therefore, it's their responsibility as you define right, and we have to think on this, we have to concentrate on this. It's the responsibility of designers to detail what should be done. I'm not saying write everything, but indication must go. What is required to be done. And if it is not done, it should be indicated, whatever mandated, whatever is specified, we have followed that. And if you have followed that, then you have done your job. In that case, we can say this work has been done according to quality requirement. We say that this has been done according to quality requirement, and you may say in that way it is satisfactory. That is beauty of contract, and that is beauty. Say contract performance. What do you mean by performance? When you say performance, means performance by quantity and performance by quality. This means contract has been or is being done according to quantity requirement, means progress, and that progress means quality included. And if you say quality is not included, then you cannot say we can't say anything about this because this is not accepted. And what I say, that's why I ask ourselves actually when I ask quality, means it is just an indication, it's just, you can say, a salutation to talk someone. Means I talk to quality, though there is no physical form of quality I'm talking of. Means I cannot say I'm talking, I just imagine this is quality and I'm interested in talking to you. And this means I am interested in talking to myself. That's the only thing, because I assume there's a quality, and quality is an imagination, an image, but it's no image. It's in my mind. Just to tell people means what I'm thinking about. It's a kind of contemplation of my mind. I talk to quality and coordination. This is neither is coordination practical or physical, neither is quality, nor both are. So we talk to ourselves that because I am sleeping, my own, I'm sleeping, I'm not awakened. Way others are sleeping. So during sleep you talk to some soul. So I miss my soul when my eyes are open, I work. So for that I say I talk to someone and I talk to myself. And myself is not a friend, I want to make it friend. Because there's a distance between my physique and my physique and soul, and that distance will be bridged by my own design. And that's why I say quality and coordination is that bridge. That bridge is quality and coordination, which is very important. And that importance forces me to do something that's required. And we say that we have to establish quality permanently. Permanently means in your mind permanently. You should not think below some level of quality. Yes, you can think of working on that, how to design that, but you should not go below that level, and you have to fix your level yourself. Nobody will fix it for you. Designer can fix and you can fix, and both can fix together. And that's important. Means here's no challenge. You have to, you can say, silver line. You have to describe yourself. Where do you want to go? And that's where engineering stands for. Engineering, as I say, products are variable. You can say varieties of products in market. Same way, varieties of construction are available in market. It's variety that you can say, somebody says, for example, you used to say in past, brick class 1, brick class 2, same way some other items. Both classes are acceptable. It depends on which one you want. It depends on budget. But both are acceptable. Class 1, class 2, class 3. Means it depends on requirements. You cannot say it is class 3, so it's substandard. No, your requirement was that. And just like this in a concrete world, grades, we say grade of concrete, M50, M60, M40, M30, likewise, M20, M25. All are acceptable depending on requirements. Means it's requirement that decide. If suppose there is M20 concrete, we cannot say it is rejected. If specification is M20, M20. If it's M60, M60. It's M40, M40. What to do that? You can't say it's inferior or superior because that's requirement. So it is what I said, specification. What do you specify? What do you limit yourself? That is important point, very important point. Limit yourself within that. And quality is not open to some constraints. I should say it is closed system, but classified. Which class do you want? You use it. Same way it is in designs, it is in manufacturing, it's in construction. You have to decide where do you want to stay. And there are varieties according to use, in residential construction, in commercial one, in industries, or you can say in some other world. In, say, for example, nuclear reactors, building, plant processing, everywhere. It depends on what you want to achieve from this material. And if you want to achieve some property, some use, or you may say some attributes, you have to provide requirements accordingly. We cannot generalize this, but we have to organize. Organization is much more important, and that organization means we have to think of. We say, when I say think of means we have to think of much more than what we think is right. Therefore, coordination engineering is that root, is that you can say network itself is a network. Coordination engineering, network not visible but network that works inside one or inside a group of people, group of personal, group of professional. Coordination engineering is that which meets you everywhere, which defines to you and you define to it. Coordination engineering means it stands everywhere. We meet many people there. People, I mean to say, at every coordinate, every abscissa. When coordinate we talk of, abscissa must be talked of. We generally don't use abscissa, but coordination itself means something is standing, something stands on abscissa. And you know what is abscissa on x-axis in graphics? We say it is abscissa, maybe on right or left, while on y-axis we say it is ordinate. So if ordinate exists, certainly abscissa exists. If value of y exists, value of x also exists. Otherwise, your equation cannot be fulfilled, cannot be completed. So when I say coordination means I have to understand that abscissa works, and what is abscissa, that also you have to define. And in engineering, it's not only coordination, if in fact it is complete, or you can say it is volumetric consideration. So here coordinates simply define, so area consideration or two-dimensional consideration. We define three-dimension also in that because of quantity involved. Quantity cannot be described just in two dimensions. It is described in numbers and square meters, but nothing is fully square meter without third dimension. And that third dimension I'm talking, and that is called, in our mind, we have to think of third or fourth dimensions, and that is, you can say, quality and coordination. Coordination is unlimited always, and its extents are unknown. It's up to you. How do you move it? How do you walk on this? It's your specialization, your expertise. How do you think of it? Sometimes we give more value and sometimes we give less value. But the value also you have to decide what value you have to give for your own coordination, because it cannot be designed, coordination cannot be designed, it has to be applied only. And design automatic works because it relates to your design. So coordination engineering, which is not very famous, but it is important and significant. It's used in field, which many times we say you did not coordinate it properly, or you coordinated it properly. Or how do you coordinate all these requirements? I heard many times many people saying, many top engineers saying, "Oh my God, how do you?" Means some their subordinate. "You have been coordinating this much. How can you find time for this?" It's time or no time. We have to do it. Just like body does its coordination itself, we don't even feel it. Everybody coordinates automatically in body. The body is such a coordinator. Body is your teacher, in fact, you say. As far as coordination is concerned, I don't accept any university or any institution of world to let me know what is coordination, because they themselves are not well coordinated. To be very frank, it's not claims of fact. We don't need any professor because professor lies in me. No professor can teach me coordination because professor itself doesn't know coordination. I mean, to that extent I am saying coordination is something in your mind. If you did not have coordination, you would not have studied well. You would not have come to this level you are. Maybe not 100% you are sure, but to some extent you did coordination and you did not realize that. It's same thing, I am using this body given by God, but I don't realize this fact. I enjoy life, I use it, but what is behind that, we never think of that. We think only when we fall sick, in that case, oh, what's the problem in my body? only that way. But in construction engineering, it's every activity that teaches us. Though we don't learn at that time, we only observe, we watch, we instruct, we do. And everybody has different way. And we learn also, but we don't realize we learn. I should say more than academical standards university. We have site university. We have site work university where you are a student, you are a teacher. You have many professors in form of seniors or in form of information. And we use that information, whatever is given to us for purpose of this work. And we learn a lot in that. We make mistakes also. Mistakes every time we make. And we do not know many times what we have to do, but we do. This means we can devise how to do. We call in our language something that you arrange how you want in this. Arrange it, manage it. And we use this arrange or manage word means this is a kind of, evolution in work. Means you think yourself what you have to do, how can you do? What way you have to do? When in engineering we say, I have to write myself my method, or I have to think on myself what I am going to do, because my objective is work. My objective is what is fixed into work, what's demanded, that objective. How I make a way to walk to reach that point of destiny or objective or a scope of work. We have to decide as far as path should be correct, that path should be safe, it should be practically workable, just like we say, without any problems, without any distortion, we have to reach destiny. And that is where we say we have to decide ourselves. And that decision is called method evolution. We have to, if it is successful, we can say this is my method, and this can be used, but at first original instant, we have to devise. Every work has to be devised, and it depends upon how do you think. You think in time value, you think in cost value, or you think only, or just you want to think nothing. And that's where coordination engineering works. That's where projects require coordination engineering for purpose of obtaining quality. And that's where public is interested in. And that's where engineers have to provide all this to support public. Public is to be supported by engineers. Engineers have to guide public in terms of supports. They have to help public in terms of quality. They have to produce something for use of public. So public, whatever level of public. And therefore it is engineer title that is considered everywhere, though people consider differently. But when I say engineer, this means where engineering is involved, that is called engineer. Sometimes our technicians are great engineers. Sometimes I see that very with whom people consider, oh, he is low class worker, he is letting. But sometimes that worker generates ideas. That worker generates ideas which help work. So what is that? Maybe it's very small part of engineering, but engineering is construction. And there may be such ideas on projects, all-time ideas. And those ideas are when worked upon, they may cause some errors also, or they may give direct output. And that's the process of learning. And that's why we say, when we work in field, in construction, on sites, though we have done same again and again, but yet we keep on learning, and to know more, or to think on more, and to apply in different way. At times we learn, and I may say that there is no formal title after this learning, and we just call it experience. But experience, pays everywhere. So our question is, in Hindi it's written Samanvay Abhiyantri, coordination engineering, and also it is written Yojanaye evam Abhiyanta evam Sarvajan, which means projects, or which means you can say projects of planning and engineers and public. And for reliable quality engineering works deliveries. For reliable quality engineering works deliveries, coordination engineering is a must. A professional engineering note for all. I am calling it note for time being, So it's not a book form, it's a very small document yet, but it is a start. How long shall it go? I don't know. But my purpose is to integrate this, link this to quality file, because quality and coordination are helpful to everyone. I did it practically, but I could not formally define that. But now a time exists that we have to define this in engineering world. I searched a lot on web about coordination, about quality coordination, or about coordination in engineering as well as quality in engineering. If I search quality engineering, I find again same boring ISO 9001 or Sigma or quality controls, which is very common, but my approach is not that. Okay, controls are all right, we have to accept them and we accept them, but product quality I'm interested in. Testing, okay, testing is a mandatory requirement, but does test prove? Means your product should give correct answer. If your product, there may be formal test, sample test, I'm not interested in that, sample test. Real test is on product. What's experience on product, how does it work? That is part here, and we can't contravene that. And that's why I say quality engineering has to be defined clearly along with coordination engineering. And coordination engineering has to be realized, has to be understood, have to be established, which has not yet established, and has to be established everywhere in every branch of engineering. I know coordination in aerospace engineering is very active, otherwise every flight would have crashed. That's active there because of safety reasons, because of functional reasons. It's active everywhere, but in construction, I don't accept that it's active. It may be called active, but there is, it doesn't exist at all. It's on individuality that action is required or not required. In construction world, individuality is very important, individual performance. Even from lowest rank of helper to topmost rank of top engineers. So many categories are available. A network of hierarchy is available, or we can say network of organizational key personnel, or which we call project organization, or in old terms project managers, project management. Though I call them leaders on project, who lead project, and those who work on project. Leadership to workship to workership, both employ together, both own together responsibilities in different levels. And that's where sometimes every part of organization chart is very important, and we have to think in that, just not for key personnel but for all personnel. And every worker in engineering is important, we have to keep in mind, irrespective of educational qualification, irrespective of whatever. We know that contribution is given by that worker, and with that contribution work is done, and it applies to every worker. And I consider here designer also a leader in construction. Design engineer that becomes a leader in construction, because without that design authorship, without involvement of that engineer, we cannot deliver designs. And if designs are not delivered, we cannot say that work can be done. We cannot say that contracts can be granted, contracts can be managed, can be organized. And that point is really, we have to understand clearly in every term. You may say that I'm talking a lot on this, every day I talk. It's not talk. It's you can say kind of inducement I'm saying. You have to do this. And to all engineers I'm talking of, don't run away from such people run away, I have observed that people run away from such acts where you have to think a lot. I don't think in designs you think a lot, you have to think a lot because procedures are available, software are available, and you have to just fill in those requirements if you have the which is called modeling. So your contribution is not that much now in designs. There was a time where there was no software, and that time designer had a role, work role, original role. But now it's secondary role in fact. It looks bad to say that, but fact remains that only it is policy role or what do you want to do is that role, and your support is very strong, software support, speed support, calculation support, and means in that level you can say indirectly software is also involved in construction of design of construction. You have to design what you have to construct, so it's all involved there. And because it's involved in there as well, means in that case quality becomes more significant than it was before. We have to achieve quality because of quality requirement and because of accuracy requirement and because of work standard requirement. And that's why I can say now every engineer should be a coordinator, though everybody will not accept this. They will stick to title only and not to act. Title doesn't give you anything. It's your work that gives you anything. And you own your name because of your responsibility, accountability, and what you do. Sometime you say this person is a site engineer. A statement is different. That site engineer is as said as means it's nowhere near you. Or you are not interested in site engineer shall be responsible. You simply send designs. Oh, this is a responsibility of site people. Yes, you are right. This is a responsibility of site people. But this is also responsibility of you people because you are also indirectly site people. You design for what? You design for site. And you always expect the site will follow your designs in letter and spirit. But you don't want to go there. That's only difference. Well, it's not that I want to talk on that at this moment. There will be other talks. Here I am constructed in coordination, engineering, because it's clearly said, and not only said, it is evident, it's evident that if you miss coordination, you miss good engineering. Missing coordination means missing good engineering. There's a sentence here, यदि समन्वय नहीं तो स्वच्छ अभियंत्री नहीं, संचार आवश्यक समन्वय अभियंत्री हेतु. We should have good coordination for clean work, engineering work. If you want clean engineering, you have to coordinate correctly, properly, timely, and also if you don't have good communication network or you cannot communicate properly, then you cannot become a good engineer. Though engineers don't worry about communication, but I think that's wrong approach. I know seniors, they can coordinate, they can write, they can do, but in beginning itself we should know when we deal, forget from which sector you are, from which you are working in government or working in private. You work in engineering, you think that way. You are working in engineering, and engineering is the world. If you are really an engineer, if you say, no, I am just having degree in engineering to enter other professions, that's different. You are not engineer then. I mean, you are not practical engineer, you are just having certificate and that's it. So communication support for reliable coordination, and that's why I say communication is support here. In more projects here, and we can say, as I explained to you last time, this is another project where in Baghdad, and this is Dar al Thawla Press Complex, and this you can say ethylene plant facility, ethylene, and also this is a shooting range. This is a process area of a plant, same ethylene plant I said before, all that. And it clearly shows many components of this project. For example, here, if you see here, we'll find processing units, many foundations, many steel buildings, and you can see substations and also seawater basin. And so much is there involved in this, though it's very small part of major project, but it's involved. And we can say seawater basin here, and we may say that, it works like that. It works like that, and we have to see that. Record building it was, we'll talk of that also. And these generally I have taken from Google Earth, don't take it otherwise, though I worked on these projects, everywhere I worked. And this is many projects from my career. And this is school building, not school building, hospital building. This hospital building, and this also we will talk of. And also we have this LNG plant, and we have discussed already, but we'll discuss in more because I'm trying to share with you my coordination approach. And this is certain building where you can say this was added last time, portrait number 10. So this added yesterday, and this is administration area, administration building. This is of RCC and amenities building, and this is also of RCC, in a small one in between two buildings. In administration building, other one amenities building it's called, and also warehouse on this right side, right end, and left end is administration building. In between left and right, this small twisted one, that is amenities building. And their warehouse is steel building plus RCC foundations. And also we can say that another plate. Now this is cracking furnaces, structural network, structural image. That's process area structure, cracking furnaces. And here is, that is flat 12, and is essence, you can say, a part of process area structure. Is during construction stage. There is another building which is also in initial stages of structure, and it was already, this is done, I'm just taking from my career project. This very small house, and you can see RCC construction there and brickwork. Say 300 cubic meters, small house, not big one, but 300 cubic meters, not a small quantity yet for a house. Soil improvement, beams, framed foundations, etc., etc. I like to add, I like to repeat this, I like to add to this one. You can say a long note here, which I can read it for you if you wish, just for information I'm talking about. And that's very interesting to know. Says the salient features of construction carried on, and salient features, and this is a little, if you can blow it, I think better. It's 150, I think we can't blow more than that, so it won't work. So we keep it as it is, no problem. Size that, so we have to see is front portion, double height drawing room or hall. This is in front, this is drawing room, we generally call drawing room in houses. And also its rear portion, bedroom area in 3 stories. We can say, before all this I can show you a little glimpse of his plan. Here if you see this, only few of 2 drawings I have put, not all. I can blow it up for your reference, it's better blow it up for you. You can see this here. It's a kind of plan here. I cannot blow more than this, so it's clear. Let me little blow it like this, 200, let me say 250, so that it is clear to you. This kind of plan, saying this is front portion and this is the rear portion here, and of course these are very at different levels drawing, and this line you say is no floor at this level, means double height, this is in double height, this, and there is a foundation plan, foundation here. This is the only few sketches I added, not all, because all I'll show you and one by one, but now I'm trying to say what I'm saying about the soil improvement, etc. It is foundation here, that's important point. You can see this is foundation here, and it's written soil improvement here. This is foundation. A soil improvement is this is a rectangle, you can say, in sections I'm showing to you, and this is foundation here, RCC foundation in this form, in form of a beam, and we are titled foundation beam here, and depth is clear here in this, but not readable maybe at this moment, but no problem. We will read this is say 200 here, this one thickness, and this is 1 meter or say something else, and whatever design thickness comes, we have to provide that. So this continuous means it's not just a foundation or isolated footing, it is in continuation all over there in foundations. I'll show you later on now. I'm just giving you a glimpse of this, what we have to talk, and I can read for you what is there, what's not there, and we can see that here is what it is. Yes, it is about this house. I did it for you so that you can understand. Again, I say what is this? This is a plotted house for the bath. It can be anywhere. I'm just taking this. And salient feature of construction in this very, very minimum requirement is salient feature. It is front portion double height drawing room or hall, as I showed to you on that drawing. Rear portion bathroom area in 3 stories, and it's a ground floor portion, 75 square meter, previously constructed in 2000. So you can say it is a small portion was constructed about 22 years back, and soil is silty clay with high affinity to water and white ants. When I say high affinity, means it is clay. Certainly, it is porous. We know that one properties of clay. It's a porous, it is high, it's porous soil, and it's of course an important one for. It's not good for foundation, but we'll talk of that. Then depth of formation level is minus 3.4 meter because it constitutes a basement also or cellar floor. That's why it's minus 3.4 meters, means from plinth level down to 3.4 meter formation level. And excavated material or excavation affected by excavation carried out by excavator, we call JCB, that's company name, but it's excavator. Partly it was done by excavator and partly by taking out soil using donkeys, because in depth machine could not go in constrained area. So excavation carried out by JCB partly, and then used donkey workers, soil removed from site. Now this is just a small be happy, or they should please to know all this, because this relate to life of everybody. So then I say soil improvement under formation level as defined below, and this is very, very smart, very, very important, significant item. Well, I think every member of such topics in construction, such topics in designs, but they're so confident in every good or bad act that I take responsibility of this. They say like this. That's not correct. We have to be realistic. Otherwise what we think we do, or what you think we do, it doesn't mean anything what we think we do. So here is a point of soil improvement, and which is very important part in construction, because ultimately soil is destiny of building. You must know that. Just like we say, my destiny is this, my target is this, target of building, or target of whatever structure is to reach soil, and soil has to reach to further stratum below, diminishing all forces on it, and those forces go into strata to become a part of earth forever. That point we have to understand. Just like we say, load distribution and distribution load to final layer of soils, which is, it doesn't, I don't look that, but it is fact. It happens. Means soil we have to worry about. In fact, soil we have to worry about. Good soil means good foundation, and bad soil means bad foundation. That point cannot be ignored. We have to consider that point very seriously because of foundation responsibility. Foundation responsibility means we cannot expect that today we construct some building and maybe within a couple of months or couple of weeks it should fall. That is not acceptable. But it happens because of all these reasons. People do not value soil. I have seen, I have experienced people in general do not value soil. This is a fact. This is a fact, and we should not deny this fact. Even I think engineers who have some knowledge of soil, they don't care for soil. And there are many people who have just no knowledge, but they continue without it. We should not forget that soil is a part of civil engineering, and it's very significant part in engineering. Though we study that in soil mechanics or in construction engineering and foundation engineering, soil is studied, but at that level of student engineer, we do not take it seriously. We just take it or consider it from viewpoint of passing examination, which is also essential to pass examinations. But examination cannot be passed without having knowledge about that subject or about that chapter, whatever it is. As far as soil is concerned, we know soil cannot be guaranteed by anybody. It cannot be guaranteed. And if it cannot be guaranteed, doesn't mean we should not care about that. We should not study that. Soil study, it to be very, frankly speaking, what I noticed that, of course we are engineers, but when you have some degree, it doesn't mean that we know everything. Only meaning is that we can understand this. And soil is one of such subtopics, such subjects, such domain that if you go on sinking into that or drawing into that, it receives you all time. After all, it is some structure. Every soil has some structure, and based on that structure, names are given that this is fine soil, or this is grey, this is sand, or this is clay, or this is silt, or this is limestone, or this is peat, or this is whatever we say. And of course, stone, you can say some big stone builder, as people reimpose their thoughts or reimpose their wills on soil in past or now. There is no homogeneity in sections, there is no homogeneity, and you can say somewhere it is mixed up with other materials, And when we investigate soil by exploration, we can at that time know much more information of localized soil survey, localized soil work, or at whole state or nation that has no development yet. But we have to be very careful about this, and that's why I say soil improvement by filling what we did is there. How I did this, why I did this, because I excavated and found that there was no good strata even at that depth, which is say more than 3 meters. And this also means that if that depth is not available, then there's a question of risk involved. And we have to understand that risk. Soil is, if you say, I would say it is top profile material that is used in construction. So we say we are not using it, it's already there. Yes, it's already there, but ultimately it will use you. It shall use you forever. My point is very clear to you. So how to improve soil, and that's very important point. How to improve soil. If we cannot improve soil, we cannot use that soil perfectly. And as we know that we talk of clay or silt, both are compressible. Compressible means these can be declared to lose volume and to gain strength if it's clay and keep on being pressed. If it's in certain water moisture form, it's quite it's quite dry. That's different, because when there's no water in that, it shrinks in volume, or with water it enhances its value. So we say soil improvement by filling 40 mm. Now how to think about, what to thought, what actually we wanted to create there, because the soil was not sand or limestone. It was not even of metamorphic nature. It was, we had to produce two items like that. Steel work we had to do, structural, RCC using steel, and we have to do all other such items where vibration applies and where concrete hoisting is applied, and then we can say that machine, whoever done on site, used on site for soil improvement, we should improve it. And we had to remove bad soil, that is clay soil, from that foundation and we replace that portion which we remove by some other good soil, so that it doesn't cause any upheaval or loss from ground in coming time. That's why I'm very keen, very interested in sharing with you soil engineering. I'm not expert, but expertise means you have to be in touch with that, and that expertise is nowadays digital world. That part we have to understand. So what we did there, about 1 foot, I think, we removed dirty soil, or you can say expensive soil, and we replaced that portion. It was in addition to your formation level, I say. From formation level down, we changed soil, we removed all bad soil and replaced with graded material, and that's what I am trying to reflect here in this talk, which is of course very significant one, and we have to be sure of all our actions. And I can say here I written soil improvement by filling 40 mm graded aggregate, and that is 250 mm thick, followed by placing 10 mm graded aggregate into that voids of 40 mm. Means 40 mm voids, 40 mm graded aggregate voids were placed in by, were fulfilled by 10 mm graded aggregate. And after that on, that placed graded machine dust. So first item is ships or aggregate, within which further down aggregate, and that which either or that. After this, when these voids are filled in, we had to above mix compacted, was compacted dry as well as wet to densify mix, or to compact mix, you can say. Densification, it is direct compaction to a certain level it should be, and then you can say compacted dry as well as wet to densify mix whatever we laid to at every stage. Now we have to say we compacted that one, right? And what happened? Bearing capacity improved because of graded material, and it improved sufficiently, satisfactorily. And we can say if it is graded material, compacted one, settlement chances are reduced. Settlement chances. Settlement of what? Settlement of direct soil in contact. Direct soil contact. What I did now in past of this reference to this is that observed one pit 1 meter by 1 meter by 2 meters deep for about 6 months. There was no problem in excavation, and there was no requirement of any shoring during excavation. No requirement shoring, because self-standing soil it is. Self-standing soil, though it's not still, but because of spaces within, or you can voids within, it doesn't work more than that. Which says, in this pit I observed for 6 months, there's seen no problem in excavation, and there was no requirement of any shoring during excavation. That indicates that soil was self-supporting due to having an angle of friction, that but due to possession of high value of cohesion. Substrata did not have any water table, but certain moisture, very nominal, a certain percentage of the moisture. It appears that land was for purpose of agriculture in the long past and for development of area. Development Authority absorbed in December So we can say that, as I said in this, I repeat, there was no problem in excavation and there was no need of any shoring during excavation, but that indicates that soil was self-supporting due to having no angle of friction, but due to possessing high value of cohesion. Substrata did not have any water table, but certain moisture very nominal. It appears that land was used for purpose of agriculture in past, and for that development of area. Development authority acquired land for urbanization around Delhi. Soil density contained certain soil contained certain organic chemicals that had to be avoided to inner to import adverse to impart adverse effect on building. This was done soil in those days. There is nothing to know about that. Alright, then you can say, fortunately, I have experienced during my career extensively on RCC building projects as well as on industrial or industrial and shore projects, both in office engineering as well as field engineering. Based on this experience earning, I could solve proposal easily, which I did comfortably with full confidence successfully. A decision was made to apply soil improvement technique in easiest way so that bearing capacity of that soil, the bearing capacity of soil as well as permeability of soil below formation is sustainable. I say sustainable. Water should not affect foundation. If water is allowed to move beneath, then remain beneath. Then we can say just next paragraph, say there should be water should not affect foundation if water is allowed to move beneath foundation structure. Clay soil had to be isolated from building and substructures for purpose of RCC protection. It's very important paragraph in this, that there should be no water in foundation. It's not impacted. And we can say a decision was made with bearing capacity as well as permeability are very important here. Of soil below, water should be added or should be added or not to the site. It's a very important part. We'll decide that. And to meet this requirement, we can say this fill or soil improvement. It is a kind of a small road structure. So road structure, water bound by kind of road meet requirement. I decided to form a road type structure below foundation formation without involving any cementing material. No need of cement in that, no requirement, but to included just water bound. And some suggested me to use lime also, but I did not convince me. It didn't convince me as lime is not a reliable material in moist state or moist environment. I went ahead to excavate prior about, you can say, yeah. So we have to concentrate on these points very one by one, and we'll see what is that. Then I can start some. I went ahead to excavate about 300 meter additional depth to accommodate proposed soil improvement to a minimal meeting. It could be more by, but I said I did not intend to have risk, to take risk more than that due to excessive depth of excavation, where on two sides existing building. Let me put on battery please. I think it may be dangerous now. It's 27. Let me take care of this. I will go away. Let me take care of this. Why this will stop. My dear friends, what I'm saying is all practical coordination or requirement, you can say. It may be coordination, maybe requirement, whatever it is, it's all for practical purposes. You may now see further about the written here. I did not take any risk in this. It could be more, but I did not take any risk more than that due to excessive depth of excavation, and 3 buildings were there existing around, and 2 sides existing buildings up to 3-story located. So I didn't want to have any risk, and particularly in such clay soil, which I see buildings otherwise doing. People working in soil and don't worry about buildings around, but that's a very bad habit. You see, it's clay; it can deceive any time. You see, be very sure about that. You have to either provide supports of scaffolding or something. You have to provide some system that soil is retained properly. Alright, then now you go further. The formation was prepared, or you can say well dressed, and you can say it was made ready to receive soil improvement related aggregate. Formation was prepared, and 40 mm aggregate, which is called Wapsi in Delhi. Its name is Wapsi, trade name, not actual name. It's 40 mm aggregate, normal aggregate. This term was used to be placed first. So as part of soil improvement, we brought 40 mm aggregate and placed a spread on that area of whole foundation. 10 mm aggregate was placed on that, on 40 mm aggregate. Means first 40 mm, then 10 mm, which will fill voids of 40 mm automatically. And we can say 40 mm aggregate, and you can fill 20 or 10 also. So we fill 10 aggregate because 10 is more significant, and to have better packing we also call this tandem aggregate a kind of language is Jira. People call usually Jira. No, they don't know what's tandem aggregate. So we can say 40 and this Jira tandem aggregate, so that they are combined and voids are filled. 40 voids, aggregate voids are filled with tandem aggregates, and we can say later additional layer of machine graded dust. Additional layer of machine graded dust was placed. Dust, stone dust. Machine graded dust was placed, so that voids within 10 aggregate be filled with mechanically produced dust. All was watered and compacted. Just as it is done on a water-bound macadam road structure formation. It was noticed after compaction that the formation was very strong, and there was much improvement on safe bearing capacity, as we see. And that was our milestone to increase bearing capacity of formation level. Sorry. So this was just one very small part of improvement. And so for the foregoing fill, we call it fill. Of course, it's improvement part, soil improvement part, but fill. This fill has to respond to work. Foregoing fill has to respond to work as a permeable medium. Permeable medium also for down-flowing water. What do you mean by that? You understand? Permeable medium. What I mean by that? It is a graded section. You can say it is graded fill. Graded in a sense that 100% voids are not filled. Permeability factor works there. It's not now porous. It's opposite to property of clay. When we talk of clay, we talk of porosity, pores. Clay has pores. We cannot fill those pores, and that's why we call that porous soil. Clay is porous. It can have much water content in this, but these water contents cannot move, cannot be mobile. But when sand is concerned, when you see sand, it is opposite to clay. Its mobility of water is permissible in sandy soils. Same is here. Porosity doesn't work in this graded section or graded strata, but water can pass through in laminar flow. I'm not talking of turbulent. Laminar flow, you know what is laminar flow, where there is no turbulence and viscosity is higher than, in some way, Reynolds number, we can say. Well, permeability provision helps water to flow successfully below foundation. It may not impact adversely on concrete. So what it says, foregoing fill has to respond to work as permeable medium also for down flowing water, as well as to allow a break for upward flow water. In future, that could be a result of heavy rain or whatsoever reason. This provision has also affected as barricade for clay soil to be in contact with foundation. Means we have removed clay. Clay shall not be in contact with concrete, as it usually happens in clay soils, where you fill that material itself without knowing merits and demerits. of that material. So we can say, in addition to this, we say, in addition to this, or section we say, on sides of fixed retaining RCC walls built between main columns and fill material used is reverse sand so that it allows water to be permeable, since clay does not possess this property but considerable porosity. You see, in what I said in that clay properties and also what we did on that foundations, we have walls there in basement. It's called retaining walls. We prefer RCC, not block work. And I say RCC in walls. Now we go further and see what it says. As I'm saying about retaining walls, there are retaining walls in that, and there must be fill around. So we did not fill clay in contact with wall, but we, for some width, let us say some width, we filled river sand around foundation walls, around basement walls, so that permeability continues. We can say, in addition to above these explanations, on sides of fixed retaining RCC walls built between main columns, fill material used is river sand so that it allows water to be permeable, or water to permeability. It allows water to permeability, since clay does not possess this property. But considerable porosity, porosity is there, but no permeability in clay, this property of clay. You know that. And if you know, you know now that water cannot flow freely in clay soil, but can flow in graded soil, as we said, which includes sand also, as graded mix. Virtually, foundation built are soil contact free, no soil contact, and portions between all RCC beams, foundations, joining columns in both directions, exclusively river and sand, river sand. So we can move further. What do you say now? In addition to above, I have said that in addition to above, on sides of fixed walls built between main columns, fill material uses river sand so that it allows water to permeability, since clay does not possess this property. But considerable porosity, virtually foundations built are soil contact free, and portions between all RCC beams, foundations, joining columns in both directions, exclusively river sand was used as filling material to avoid cumbersome work of compaction of soils, either to be taken from site or to be imported, and we avoided compaction layers because sand is compacted properly if it is driven. Now we go further on this, that we got this improvement, and we fill we use river sand. Of course, we avoided time wastage. You can say beam foundations were used between columns in both directions. Exclusively river sand was used as filling materials to avoid cumbersome work of tank. tank. Now we go forward. I think the work has been done economically in all respects, including foundation, what it necessitated from practical engineering construction viewpoint. Now, what is that we're talking of? Oh, that's a very important point. On prepared soil improvement, let me see, I'm seeing a little cold, why it's cold, that's the important point is. (14°C) and dew point is 8°C and it's a little less than 15, so expected is 27 in day and 13 night, so it is 14 degrees now with 45% humidity and 8°C. 8 degrees point is dew point, and that's why I'm feeling a little glossy now. So we are talking on prepared soil improvement base, a 50 mm thick layer of blinding concrete. A 50 mm thick layer of blinding concrete was laid. It can be 50 mm, you can do more also, no problem. But because we have already laid graded bed, so 50 mm is okay in this case. Surface of blinding concrete waterproof using C-coat tapcrete. So tapcrete applied waterproofing coating applied on this blinding base. Surface of blinding concrete waterproof using tapcrete coating protected by plastering on coatings. This little thickness plaster on the surface. There is no surface. So you can see on prepared soil improvement base, a 50 mm thick layer of blinding concrete was laid. Surface of blinding concrete waterproofed using tapecrete material and protected by plastering on that. Analysis of structure done using Carney's rotation contribution method. I discussed with you long back. It is an Excel file. I'll show you otherwise later on. What is that? Excel file, if I show them, you have to show separately, not in talk, because only one format is acceptable in this talk. You can see that surface of blinding concrete waterproof and analysis of structure done using Carney's rotation contribution method, which is very simple in fact. I usually like this when I do rather than advanced softwares. I just tried this software on the back and brought to my use. Surface of blending concrete was tape treated, and analysis of structure was done using garnish rotation contribution method. Analysis of foundation frame matting done by purpose made worksheet. We did ourselves depending on what is theory application, and worked out ourselves. That's the only way. We see now analysis of foundation frame beam done by purpose made worksheets. We have many sketches in this. I'll show to you, and it is the foundation is shown in one sketch. I have shown already to you 400 by 200 mm, 400 width and 200 depth of beam, and 800 mm wide spreader embedded in full 200 mm thick RCC matter under all beams in both directions. Columns to come up from these junctions of columns and beams. Columns were revealed from beams, and you can say in between some columns 16,000 liters capacity water tank being provided between foundations beams. Between beams, river sand filling provided in place of soil for purpose of natural compaction. Externally 450 mm width sand bed. So we continue now. It says that structure I'm talking sketch shows details of foundation sections 400 to 100 mm beam with 800 wide spreader embedded in full 200 mm thick and RCC matting under all beams in both directions. Columns were revealed from beams. 116,000 liter capacity water tank storage has been provided below between foundation beams. Now between beams, river sand filling could be done, provided in place of soil, and externally also, 450 wide portion filled with river sand, while remaining soil but with 400 mm line. There is no contact between soil and foundation anywhere. You can see these sketches, and here is one is foundation, other one is one plan, and other is another plan and roof. So these are only sketches, we'll discuss later on. And here is retaining wall, which is 200 mm thick work with. This is retaining walls. Retaining walls 200 thick, provided around foundation to hold, fill material around. And now retaining walls to handle thick provide around foundation. To hold fill wall reinforcement with 8 mm rebar. So retaining wall was there. Now we say we can just show a glimpse of this writing first. You can see this foundation. Now retaining walls 200 mm thick provided around foundations to hold fill. Wall reinforcement with 8 mm bars, rebars at 200 centers both ways. Main hull portion allowed 12 columns, 1000 into 400 mm 4 columns, while 600 by 400 to 400 mm 8 columns, 600 by 400 and 1000 by 400. Hall columns are 1000 by 400 mm total height, and 4 columns 600 by 400 mm 8 columns. It's also total height. Span between columns 11 meters in 2 frames, that is in hall 11 meters in 2 frames, while 8 meter in 3 frames. And it's 8 meters, of course, 11 meters and 8 meters. Certain frames are located in double height area. Front allowed 1800 mm wide balconies, while sides 1000 mm wide. 6 beams provided in front balconies at both levels. We'll show that and later on. 6 beams provided in front balconies at bottom. I think if you see this, I think it's clearly here. If you can see, I'll show you that sketch. I think it's somewhere in plates. It's somewhere in plates. If you go back. This is balcony, front balcony. 1, 2, 3, 4, 5, 6 beams. 1, 2, 3, 4, 5, 6 beams, and this is 1.5, 1.8 meters cantilever beam. And on sides they are saying not this one. On other side, I will show you the next time. 1 meter cantilever slab. This is more than 1 meter here. This is 1 meter here. Likewise, this column, as I say, this column is 1 meter by 400. 1 meter by 400 mm, and this column is 600 into 400. This column, and this column, and this is beam 600 mm deep, and this is all repairs, epoxy repairs. You can see here some, and this inter beam and this cross beam, just for purpose of this. We can see this design and this design are typical, and also you can see internally same designs there, columns. This is these 2 stories new, but this story here is old one. It was done in 2000. This portion, if you see that one, this is how the building, and you can see that. This is the roof here. We'll show you later on. This is glimpse of what I said. If you see basement here, you can see that 3 columns here and 2 columns, one here and one is the other one. Here, if you see this one and that one, this column, main hall column, and this column, and as well as you can see this column is also main hall column, So this is one frame, this is another frame, and this is another frame. Likewise, these two frames are forming house, and there's another one, 3-column frame here, staircase is here. It's a staircase here. You may see that. This is beauty of this building, structural beauty. You can see that. Here is that one. So that is I reading for you. It's written here, and it's there. You can say retaining wall. It's a little boring there. I'm going slow. So cross beam is just show to you just now. Cross beam 203 section. Stair waist. Stair waist is 200 mm thick. Of course, 12 mm thick stair waist with rebars meshing in top and bottom layers. Not ordinary stair as usually we do. I converted that to beam. Beam. Top mesh and bottom mesh. That's 800 mm mesh. Here all suspended slabs included with 8 mm rebars at 200 mm centers. Both top and bottom, no temperature reinforcement, main reinforcement board, one reinforcement. You know, it's like double reinforcement. Steel beam theory, you can say here. Tension reinforcement and compression reinforcement are equal. We provided this compression reinforcement for purpose of reducing deflection as well. Though it's deflection not much, but we did that in slab. You can say kind of duct arrangement provided in slabs, suspended slabs. A kind of duct reinforcement duct it is. And it adds to control deflection as well as providing upheaval controls or hogging controls as well as sagging controls. You may say it hogging moment controls or moment resistance that can hold hogging and sagging shapes. Means sagging control not allowed and hogging is main consideration. Is trying to tell you what is this. So all suspended slabs included with 8 mm rebars, reinforcing bars at 200 mm centers, both top and bottom. And we can say rear bedroom, R is missing here, no problem, we'll check it. Rear bedrooms portion constructed with 11 columns, 300 by 300 mm into 450 mm section. 300 by 450 mm sections for spans do not exceed 5 meters. A quantity of 250 cubic meter RCC constructed using M30, M25 grade concrete. Coordination engineering is a must on every project. It's a very important one. When we talk of coordination, we talk of our own work, our own controls. You may call it self-control. No one to control on you because your ideas, or your thoughts, or your contemplations, your internal mind's working is immersed in that. There's no one to tell you what to do. You have to search out yourself what you have to do. It's engineering work, it's engineers doing, it's not, there's no person who doesn't know engineering cannot do coordination, that's also required. Coordination is automatic. There's no, you have one object is coordinate object, and you yourself is coordinate, and other part is object will act as coordinated for you. So you and object coordinate, and you have one relation, and they have to link to other relation, and it's called coordination. And there can be many persons in coordination, there are 2 persons only. That's also beauty work. Coordination is your own design, how to design coordination, though it's not designed, but we can take in that way. You have to find out requirement yourself, and that's the design. You have to find out requirement, how to adjust this, how to allow this ball basement major beam, and the next goes to. Very important points are there everywhere. We have to consider those points. And when we say designs, construction, and controls, they are very absolute items in construction. Beauty of, you can say. I'm not claiming that don't use BIM, but I think BIM stays in your mind. It doesn't stay anywhere else. It stays in our minds, and we have to control that. Now, there are certain points that we can say what are important here. Means you have to think yourself. We cannot depend on others to let us know what to be done. We have to do it ourselves. Coordination is a process of mind in relevance to information, competence, and practically speaking. I'm not defining that. Coordination is a process that works with the mind. It doesn't tell you its physique, but it tries to tell you where you have to refer to. When some question is asked by mind, question is replied by mind itself. Or you use your mind, you ask somebody, some other person who relates to authorities, and they raise question, I want response of this item. And then mind says that you have to search documents, and once you search document, you find relevance. So your mind accepts this. That mind says, yes, this is workable, this is preferable. And likewise you can say coordination, it is self-question and self-answer. Self-questioning and self-answering. This is self-question because you are sure about that job, already completed few percentages, and rest time you are going to catch them further. You have to open them further. It's therefore coordination is not dependent on someone else. You are your own coordinator. You are in your own machine. You have complete information. Just think of that. I showed you that bag containing this file. The bag is 50 or 40 now, I think. 43 partners with that. 43 partners. We can see coordination is your own research. It's your own selection. Don't trust others if you think that you don't find an answer. Only grid loads will be defined somewhere in building. Coordination is a self-declaration, it's self-attempt, it's self-understanding of your process, your project, self-extraction of information, you can say dig out information, which is self-extraction. Extraction is more viable, practical word. And coordination means it's not that you find out information which is required, but complete information. You should know what the scope of work requires and what we have to do. You have to tell yourself what is required and what has come out of that you require. You have to decide yourself which subject you have to deal with. Your drawings tell you what is requirement. You have to find further details yourself. And that is where important point is. And then you talk of those persons who know that. What we need, how do we need, or we can stop work there, we can continue. Because having even 5 minutes talk sometimes in 480 days, yes. Now, when you decide about coordination, we have to pinpoint your coordination means I have not written here, but you have to do that. This means you have to understand what is required. Coordination is not clearly understood. You cannot do it if it is not understood. And of course, you are one of those. If you ask for everything you did, every work you did, you must keep record. If you don't have, if you have, okay, do that. And it's wasted of energy, it's wasted of human resources. Coordination is not clearly understood. A Mannian factor means that without adequate, efficient coordination in professional engineering works cannot be successfully complete, cannot be done. It's choice, actually it's no choice, it's mandate requirement. Coordination is done, effectively done practically it is done. That point we should understand very well, and it relates to quality. In fact, it's part of quality. Everywhere, everywhere, everywhere. Here also engineering detailed deliberations must. Means information must be brought to those personnel who require it. It must be provided in right time, for right requirement, and quite rightly duly originated. In name of some unrequired suppositions, we should not do that. We should not run away from requirements of you can say coordination. And coordination means it involves every engineering topic, wherever you must not just particularly I'm talking of foundation point. It says that requirement cannot be stitched together. We have to understand these points very clearly, that dissemination of engineering information about quality requirements and how to do that, all very significant points. And if we can do that in a nutshell, we can be meaningful. I have experienced, interacted with people, engineers, that for many issue of coordination does not suit. They don't want to coordinate but just seek information. Also we can say when we talk of coordination, we talk of something very concrete. We have to understand that point. No mixing should be allowed in coordination. It should be real coordination, factual coordination. And coordination means whatever solutions we chart out, that should impact on adjacent member in both directions. So that part also we have to keep in mind. It's not simply a structural or architectural, it's a combination of both architecture and structure. And generally when lot work you have to do in coordination, in work in physical form, and that is really very much appreciable, but very much it means intensive coordination you can say we have to do to find what we are required to do. So you may say coordination we can define likewise that all disciplines involved on ongoing activity, all disciplines must be clearly described and detailed so that no information is left out that could hold progress on activity or part of whatever activity. That point you have to be very serious about, really very serious about we should be in that case. And because it is coordination issue, it's very very critical issue, in fact critical in the sense that people do not conduct it, and that is really worrisome, and it affects, now it is 13 degrees, it affects everyone, because this is very very important material we have to. That's the reason I always stand in effects of coordination, and I've started this title coordination because it's missing and no seriousness is seen because of I don't know what's factor unknown. We have to be serious about that. I'll be back in a couple of minutes because of I'm going up to come back and we will see how to do it perfectly in a proper way. coordination cannot be taken for granted. We understand this, and it's a very important point here we have to see. We cannot take it for granted. Coordination will take granted. No, we cannot take for granted. It has to work. And as I said in this note, that engineers have to understand this. They should understand this. You see, if even one small information is not given or is held without having adequate details or is not formally confirmed, activity can stop and it holds work. Or work. And there are so many other reasons are given in this. We're not going to just now, we'll take later on all these reasons can wait, but intention cannot wait. Intention cannot wait. That point we should not forget. Coordination among members based on good communication. We should not forget that it's also duty of ourselves, engineers. This is our duty to let them understand through whatever communication means. We have to explain to them technical requirements, concrete particularly. We have to tell them why we should not add more water, why should we maintain temperature of concrete, why should we cure, and at least this we can tell them, we can educate them if we know them. And also, in addition to coordination processes, which is a continuous process, in fact, we'll also take up some concrete technical requirements from specifications. Sometimes this, sometimes that, so that some information is given to you. I also discussed with you many methods through many videos, many method statements, and also quality issues. And also I'll take up some designs, architectural town planning coming time. And that's, very important facility. That point we have to consider in one way or other way. If you read point 51, what it says, when it is stated about quality requirement, when it is stated about quality requirement, which indicates that quality must be used for purpose of conducting coordination and discipline execution in each and every respect. And that's why I say, unfortunately, quality requirement has been misled, and its failure has been happening by misunderstanding about quality discipline in its entirety. Quality works in each and every discipline in life as well as in every profession, whereas engineering is no different. Quality must be used as a requirement in all works, including work of quality and coordination. And factually speaking, individual quality is known by its professional personality, efficiency achieved about degree of work or production quality. Incumbent professional possesses and then further assessment can be calculated or charted out about to know its level of work and specifically coordination competency attained by individual professionals. There is no other way that exists that quality can be achieved proficiently without working on expert coordination for doing right work first time, every time, and controlling on it use of each and every resource at optimum level. Certain points that are required to be discussed for purpose of project execution or prosecution, or one can call it organizational handling, respecting construction work activities in both disciplines of site work as well as coordination, without which works cannot be completed in each and all respects or every respect. And for this purpose, it has been attempted to write certain points herein so that one could get an understanding about works requirements in profession of building construction as well as plants, facilities or processing plants, constructions, which points certainly details out in line to follow off required works. Again I say, for me, quality is a destiny, it's an objective, it's a mission. But coordination is also parallel to that, because in this mission, coordination is very important. As coordination is important in project mission, where there is a project for someone, or you can say itself professional goal we have to achieve. It doesn't mean to have higher position only or to get more salary or remunerations. My goal is not that. It was never, had never been. How much you can know, how much you can experience, and how much can you apply. You see, we have experience. If experience is good, it's worth, it's reliable, then we can improve it by further applications, because we have learned a lot. But if you do not learn anything new, we go just the way it has been going, then that cannot be called professional work or professional act, because professional work requires further advancement on advancement and further advancement on that advancement. That point we have to be clear about, we have to be sure about. That's very important point. We have to be ready for answering every question, and in fact that is very important one from every walk in life. Meanwhile, you can read some document here, you can follow it down to some extent. Something you can see if you can find from this, and I'll come back and close it. Meanwhile, just a minute please.